Okay. So the idea behind this workshop is to actually teach on-chain automation using Clockwork, because it is not going to be a workshop that is aimed to teach how we can build a sort of a bank, dApp, or DeFi application. That's why this program does not have a token transferring or sol transferring or anything like that, or any lending or borrowing system. It just has a basic integer that is stored for the user balance. It does not play around with actual tokens. But the main thing that it focuses on is how we can actually automatically or periodically increment that balance number after a certain amount of time, like how banks pay interest returns to us. So we'll be using Clockwork for this. For those who don't know about Clockwork, it is a really cool application. It is a really cool tool for us developers to do on-chain automation. So it allows us to perform various type of automation. So for example, if you go to the docs and go to this trigger section, so it allows us to trigger automation on the basis of account change. So let's say an account's wallet address, let's say an account's balance updates, let's say an account receives some sol or transfers some sol, then we can trigger certain automation in our program. Then similarly, we can have a cron job as well that will periodically run an automation after a certain period of time. That is what we are going to be using today. Then we have this now trigger as well that calls the instruction immediately. So for example, if we have two instructions and we want instruction B to be triggered as soon as instruction A is triggered, then we can use this thing as well. Although we can always just call both instructions together in the client side, but if we wish to automate this as well, we can do it on the program side as well using Clockwork. Then we also have these other automations as well. You can go through the docs if you want. I will share the link. How do I open chat here? I suck at Zoom, guys. Here do I do? I'm not able to see the chat option here. Okay, never mind. I'll share it after this. But yeah, that was for the triggers. Let me show the dApp that we'll be using. So I'm running it locally right now. The code, you can find it here itself in this repository. You can just clone this and just do yarn install and yarn dev. It's written in the instruction as well, all the way down, I think, or no, it should be up. Yeah, so you can just launch the front end by heading to the app directory and do yarn install and yarn dev after cloning this repository. I have done that. So I have this app set up. My wallet is connected. Now I can enter my name, let's say Bolt, and enter any initial deposit amount. Once again, this is not any actual sol or actual token amount. This is just an integer value that will be stored on chain in our account. So I will create an account. Confirm this. Now I will be taken to this dashboard sort of thing. Now here I have deposited $10 as my amount, and I will be getting 5% per minute interest return. And this balance will update every 10 seconds, like you can see here. So if you wait for a few more seconds, there it is updated. So I have received 5% per minute return. And for that minute, if you divide by, if you divide it by seconds, then for 10 seconds, this is my return. If we wait for a minute exactly, then we should be able to get exactly 5% of 10. It will keep on updating every 10 seconds. We can always change the amount, change the time it will take to update to some lower value as well. For now, I have just set it to 10 seconds. You can change it to 2 seconds or 5 seconds or anything like that. And then we can obviously deposit some amount if you want. I deposit 10, so it should update to 20 or something. Yeah, there it is. Similarly, I can withdraw as well. Now, this is just integer value that is being stored in our account. So it is not asking for any token transfer or anything like that. And we can have multiple accounts as well. So whatever account you create will also show up here. And finally, you can delete the account. So the goal is we will be learning how exactly we are able to automate this thing here. How is the balance being updated automatically? So for that, we'll be using Clockwork. So do you guys, have you guys written any Solana program before in Anchor? How many of you haven't? Oh, there is the chat. Okay. Okay. Memes or have. Okay. Not written. So, okay, so I think some people probably don't have a deeper understanding of Solana programs. Yeah, I can see it. Vaibhav has not as well. So I won't go deep into the technical part. I will just try to explain the flow and where we are incorporating Clockwork in this general Anchor program, and we are able to automate this thing. So first of all, I will be using SolPG for this, because especially for those who have not built any Solana program before, let me tell you that with versions, we have a lot of problems, especially with the latest Solana version and Anchor version. So there are always some of these problems with installation and matching correct versions. But SolPG eliminates all this because it's a browser-based IDE, so you don't have to worry about installing something or anything like that. And the cooler thing is you can actually test your programs right here. You can check the accounts you have created, and you can call these instructions from here itself in the UI. So that's why I will be using SolPG for better explanation. Now, starting off, we are defining some important constants here. This is the imports and declare ID is the general anchor stuff. You will be like, we just use it every time. If you build any anchor program, that you will understand this. But the important thing here are these constants. First of all, we have this minute interest defined. So we are defining that we want 5% interest return every minute. So that's why we are we have written here 0.05. Now you can obviously change it to anything you want. That is why if you go to this repository once again, there's a SolPG link as well. So you can open this link and you can clone this entire code by importing it here. Just name it anything like that. I'll just name it demo. And you can just play around with it and build your own program by entering build here, or going in this section and clicking on this button. So you can play around with this yourself, with these values and stuff to have a better understanding. But for now, we have this minute interest for 5% interest every minute. Then we have this cron schedule here. So this looks a bit confusing. Basically, we are defining after how much amount of time we want to add the interest to our balance. So we have this website that I have commented here that is called crontab.guru. I've shared the link. So if you go to this website, you can easily create this string that defines the cron schedule. So let's say I want to, so here I have defined it for 10 seconds. So I can enter something like 10 here. And okay, that is for minute. It does have a second option as well. But you can just play around with this. You can click on this random button to see the random values. For example, this syntax here means that at minute 23, past every second hour from 0 through 20. So you can actually get the description of the cron schedule itself with this syntax. So because this is a specific format of writing this, and it's similar to, let's say, regex, regular expressions. So not everyone knows it, but you can just use this tool to create this syntax as well. Then automation fee. So Clockwork has this concept of threads. So threads are the basic building blocks of any automation. If you go to their documentation, docs.clockwork.xyz. So Clockwork has built this thing called threads that are the basic primitive type for Solana developers to implement automations. So thread is basically an account that actually calls instructions in your program to automate anything. So whenever a thread is executed, it requires a certain fee. And that is exactly the same fee we see here, or automation fee. Now, if you want to see how much exactly does it cost, once again, this comment right here will take you to their website, where you can see the automation fee required. There it is. So it explains it as well, why the fees is required. It's not transactions fees. It is a fees to actually pay those people who are running the automation workers. That is a Clockwork specific concept. But essentially, it requires 0.000001 sol per execution of instruction. So let's say you are creating a program that will call a specific instruction or automate a specific instruction every 10 seconds. So for each instruction calling, it will require you this amount of sol. So for 10 seconds, it's requiring this. And for a minute, that would be 10 into 6, because a minute has 60 seconds. That would be 0.000, this amount of zeros, 6 sol. So that's how it basically works. It's pretty simple. Then we are defining the seeds here. So seeds are basically used to derive any PDAs in Solana for those who have not created an Anchor program, this would be a bit confusing, but essentially this is basically a string that we use to derive any addresses deterministically. So if we throw in this string with some unique ID to our Anchor program, then it will return us the same wallet address that we can use to perform any specific action. It would be a bit hard to explain it right away from here to those who are absolutely beginners. But if you have any questions, you can just drop me a DM after this call as well. I would be happy to help, but I can't cover this thing entirely because we have the time constraint of 1 hour. But anyways, let's see what all we can do with our program. So we have 4 instructions here. You can see this is the first instruction for initializing an account. Let me, I can't close the entire instruction. Let me open it in the code. Okay. So we have these 4 instructions here. First is to initialize an account. So we will be initializing our bank account using this instruction. I will expand this as well. Then we have this deposit instruction that is exactly what we saw in our dApp. In order to deposit funds, you can see here. Then to withdraw funds, we have this withdraw instruction. Then we have this for deleting account, we have this remove account instruction. And then we have this instruction to add the interest. So this instruction is not supposed to be called by us. Clockwork will call it on our behalf every certain amount of time. So this is for Clockwork specifically. I will show where exactly Clockwork is doing that as well. So let me go back. Initializing an account is pretty straightforward. We are just getting these account values and assigning them the default values. So each account will have a thread associated with it. Once again, threads are the basic, the type that are the account types that Clockwork uses to create automations. So we will require a thread to have an ID. Every single thread has a unique ID associated with it so that we can identify it as well. So that's why we need a thread ID that we must store in our bank account so that we can know that this specific thread ID is responsible for automating interest returns for this bank account. That's why we are storing this thread ID to this bank account's thread ID attribute. Then we have this holder that is also just the holder's public key. Then we have this balance. So we are assigning this balance to be the default value that we enter here. If you go back, this amount as the initial deposit amount, whatever we enter here will be assigned as the default value for our balance for our account that is created. Then we have this holder name. Once again, this name that we enter, whatever, that is assigned as a default value. And then we have this created at default value stored as a current time when this instruction is called. So there's just basic Anchor stuff, nothing specific to Clockwork here. Now is the place where we will see what Clockwork is doing. So we have 3 things required to create any Clockwork automation. The first thing is a target instruction. Second is a trigger. Third is a CPI. So let me explain this. First of all, we need to specify which instruction is Clockwork supposed to call repetitively for our automation. So in this case, we want to call add interest instruction. So if we go down, we can see this is the add instruction context defined here. And this is the specific instruction that will be called that is using the same context. So we are saying that, hey, pick this add interest context and use this in our automation. So we are defining this instruction. Once again, this is a requirement for Clockwork, but picking up this instruction is also Anchor specific stuff. So it will be a little hard for those who are not experienced with Anchor yet to understand, but you can understand the whole flow here as well. So we are just defining that this instruction is supposed to be called. Second thing is, this is pretty simple. Everyone can understand this one. We are saying that what kind of automation we want to perform here. So Clockwork allows us to perform these type of automations that I was mentioning at the beginning of this call. So we can automate something when an account changes. We can automate something on the basis of a cron job, and we can automate something by calling the instruction right as a specific instruction is called. So right now, we want to use this cron instruction. You can see we are getting this from Clockwork because we want to run a cron job. A cron job is what? We are basically automating something after every X amount of time. So for our example, we want to call this cron job every 10 seconds. So that's why we will pass a cron schedule in the schedule parameter here. So this cron schedule is coming from the string we defined here. So we want to specify this in this format. Once again, you can go to cron tab.guru to get this string for any time interval you want. So we have this string here that we are saying that, hey, use the cron trigger and use this schedule for that cron trigger. Skippable, well, skippable is so that you can skip this instruction anytime you want. You don't have to worry about it too much because we won't really be needing it. You can just set it to true for now. The third thing is making a CPI. So CPI stands for cross program invocation. So CPI is once again a Solana and Anchor specific concept, but the basic idea is that you can call a specific instruction of any other program using your own program. So let's say we have a program A that we are coding, and we have a program B that is already coded, and we want to call any instruction from program B inside program A. So we can achieve that by using CPIs, that is cross-program invocation. So in this case, we want to make a CPI call to Clockwork's program and tell it that, hey, we want to create this automation. And for that, we want you being Clockwork here, to create a thread account for us. And thread account, like I mentioned, is what is responsible for automating anything. So we are saying to Clockwork that, hey, create a thread account for us. And then we are specifying that what that thread account will do. So this first parameter is simply for creating a CPI. That is also like Anchor generic stuff. You don't, it's not like specific to Clockwork, but these values that we are providing are what are responsible for defining how this automation will work and how much fees it will take and other things like that. So first of all, we are passing the automation fee, that is this thing we defined here. So this amount is in lamp ports. One sol is equal to 1 billion lamp ports. So if we divide it by 1 billion, so let me divide it here. So you can see we are dividing this value by 1 billion and we are getting 0.005. So we are saying that the automation fee required for this automation to run is 0.005 sol. And we are denominating it using lamp ports because lamp port is the basic unit that we use every time. So we are passing this automation fee here. Then we are passing the thread ID. Where we are getting this thread ID from? We are getting it from this instruction here. So whenever we call this instruction, we are passing this unique thread ID and saying that, hey, create a thread account and assign this specific unique ID because every thread needs to be unique. Then the third argument, this thing we see here is simply the target instruction we defined, which is this. We are saying that, hey, with this thread account, we want to automate and call this instruction specifically. And that instruction is add interest. We want to automate add interest instruction to be repeatedly called. And then we have this trigger. And our trigger is straightforward. We are saying that we want this automation to be specifically a cron job. Okay, we can have different types of automation as well, like I mentioned here, but we want a cron job that is repeatedly calling this specific instruction after a certain amount of time. So far, like I've covered the basic and important concept. If you guys have any questions, you can just drop it in the chat. Then I will move it towards testing it and showing things in a more beginner-friendly way. But like this is the core stuff. So this needs to be clear. If anyone has any questions, you can just open your mic and drop into the chat. Okay. So, okay, so far, just to give a summary, we just saw that we are creating a bank account, and then we require three things for Clockwork to automate our interest returns. Those three things are, first of all, defining the target instruction, that is adding interest. Second thing is defining a trigger, that is what kind of automation we want. And third thing is asking Clockwork program to create a thread account for us and then passing all these parameters that we need. Then we can deposit amount. This is pretty simple stuff. We are just adding this amount here. Withdrawing is exactly similar to depositing. Instead of adding, we are subtracting the amount here. And adding interest. Now, adding interest, we're just using some basic math to calculate interest returns. What we are doing is we are getting this timestamp and just doing some math here to calculate what amount would the user receive after this amount, and then simply assigning this new value to this current bank account value. So it's similar to withdrawing and depositing as well. We are assigning a new value to bank account. The only difference is we are calculating what amount is required for this specific timestamp to add interest. And removing account, well, that is also pretty simple. But one thing different here is that when we are removing our bank account, we also want Clockwork to remove the thread that is associated with that bank account. So that's why we are once again making another CPI call. CPI once again is used to call any instruction in program A. Let's say the program A is being coded by us to call any instruction in program B. So in this case, we are saying that from our program, we want Clockwork to call this thread delete function that is in Clockwork's program to delete our thread that is associated with our bank account. And how we are getting this thread? Well, once again, using the unique ID we have. That is pretty much it for the program. Let me show test that will make it much more clearer. So first of all, creating an account. So for creating an account, we want to define a unique thread ID. So you can get a unique ID in various ways. You can use a UUID. You can use the current date timestamp. You can do anything, just make sure that it's unique. You can increment the values as well. For now, I'm using a date, if I'm not wrong. No, actually, I've defined it here as a string, but you can do anything, whatever. Just to keep it unique, that's the main goal. So this is the thread ID. Then we are saying the holder name. So I have defined it as test here. Like we can just say bold, for example. And then the balance that the user would be having initially. Okay. Then we are passing these accounts. So first of all, we would have the holder. So who is the holder of the bank? Well, that's the user himself that created the account. So that's why we are saying that the wallet's public key is the holder. Then bank account. Well, like I mentioned, bank account is a PDA. PDA is a Solana concept that those who are completely new here wouldn't know precisely. But simply put, if we pass this bank account string and any unique parameter, so the unique parameter is the thread ID here. If we pass this, then we will get the same public key as our result. So it is deterministic. We can just call this function anytime, anywhere we want, and we will get the same wallet address. So we want bank account to be passed here. So we are creating this, we are determining this bank account PDA and passing it here. Then we have the Clockwork program. We need to pass the Clockwork program's ID because we want Clockwork program to be used as well. And then we have the thread address. Thread address is also a PDA like bank account, but here we are using Clockwork's SDK to derive it. This is the this way of deriving a PDA is specific to Anchor and Web3.js. We do it this way, but Clockwork provides us this handy function as well to do it directly by just passing the thread authority and thread ID. And that is pretty much it. Let me call this, first comment out other things. So I'm creating a bank account. If I enter test, so SolPG allows us to enter test right here, or we can just click on test, this button here itself. If you do that, okay, so account, okay, I think some other instruction is not commented. Oh, I think, wait, let me enter some other ID. Test. So there we go. We have our account created. So we are logging the accounts, all the account that we are passing. We are logging those accounts public key here so that we can explore them on Solana Explorers. So we created this bank account. So if we save copy this and go to, let's say, Solana Explorer, then we can see this account on chain that is created. This is our bank account. Change the devnet and paste it here. Now we can see this account is created just a few seconds ago. It allocated 112 bytes because this bank account stores some information like the user's name, how much balance does it have. So that's why it has some bytes stored. But this is our bank account basically. If you want to see the data that this bank account is storing, then we can go to SolPG and use the tools that SolPG provides. So if you want to fetch a bank account, we can select this bank account and enter this public key. If we fetch it, then we can see all the data that is there. So we have this thread ID that is a unique integer array. So you don't need to worry about it too much. But the main thing that we need to care about is the holder name and the balance. You can see the holder name is bold because I entered bold here, and the balance is 11. Well, that is because we deposited $10, but since then the interest return gave us $1.01 back. So that's why our bank balance is updated already. If I fetch it again, then it should be updated once again. So that's 11.016. If I fetch it, then it's now 12.55. So I'm getting some amount of return that is 5% every single minute. And that is because Clockwork is already doing its job. So if you want to explore what Clockwork is doing and how it's doing, then Clockwork also has its own explorer, that is app.clockwork.xyz. Let me drop it here as well. So we can explore all the Clockwork threads and Clockwork accounts here in more detail. So in this case, we want to just look at the thread itself. So thread is the most important thing in Clockwork. It is responsible for calling the instruction. It is responsible for automating things. So if we change this URL, wait, I can't say it. Yeah, there we go. So Clockwork will give us more details specific to Clockwork on this thread. If we enter the same address in Solana Explorer, then we would get the generic details that we get for every account. That is simply how much balance it has, how much data it stores, but it won't tell us the exact details that we need. That is something that Clockwork Explorer will tell us. And those details are, for example, what's the ID? So we had this ID set up in the front end in our test. Oh, this is the ID we entered, bank account, then this number 10,000 something that is here. Then this is the attribute that says that whether this thread is paused or it's running. So it's not paused, it's running. That's why my bank balances keep getting updated. And then the trigger, that is this cron schedule. And we can see every single time this instruction is being called in these transactions. If we just click on any of these, then we can see the detailed logs. If you go all the way down, then you can see this Clockwork automation called this add interest instruction from my program itself. And I was logging these values in my program. That's why they are visible here. So if I go back to the program, here you can see in this instruction, I'm logging these values. That is the new balance and minute elapsed since when it was called. So that is the thing we can see here. So the new balance is 17.25706, whatever. And then this thing we can see here. So basic idea is that we can build any instruction, and that instruction can be called by Clockwork itself automatically on any schedule we want. And we can build various things with it. We can build vesting programs. We can build programs that, for example, for the account change, what was it? Account change trigger. If you go back, then we can create any automation that will trigger a specific instruction whenever an account's balance changes or account gets anything else. So we can define that as well in the triggers. Or we can build something that calls an instruction immediately. So we can perform various type of automation. We have a pith trigger as well. So that is for price feeds. For example, we want to build a program that buys, let's say, Sol when the price goes down below $25, let's say. So that is something that we can automate easily. So there are a variety of things we can do. In fact, the bank program we built, we can actually expand it and build it into an actual DeFi app by allowing users to deposit tokens or withdraw tokens or actually earn interest on those tokens. So we can definitely do that. So that's how we can build various things with Clockwork. And once again, I would definitely recommend to go to this repository, that is github.com/Solana workshops/bank simulator. So if you go here, I think the call will end in like 4 minutes because of Zoom's 40-minute limit. So I will be quick here. So you can just go here, you can open this program in SolPG, play around with it, and just read all this to run it locally. It's very easy. In fact, I would recommend you to use this. Yeah, sure, I will paste the repository. So I would recommend that you guys should just launch the front end locally. You don't have to clone the entire Anchor program locally. Just use SoulPG. It's much simpler. You don't need to install anything. Even though I have mentioned the instructions to run it locally, but I would recommend just use SoulPG. It's much simpler, and there is really no point of doing all these steps. You can see it's a with SoulPG, it's just simply clicking on this link and deploying it. With locally, we have all these steps and stuff. We have all the definitions required here and everything covered. So if you have any questions further, you can just DM me on Discord. If anyone doesn't know, it's simply Hey Bold. Any questions, just feel free to message me. Or if you want to build something, I can help you with that. If you have any questions, just drop it in the chat as well. I will answer them, or open your mic if you're comfortable. I know it was a bit fast and probably not the best explanation, but there are a lot of people who probably don't know about Anchor programs well here. So trying to balance between those two was a bit hard. So it was probably not the best. But okay, good starting point to learn Rust. So I would actually say that you don't need to know hardcore Rust in order to build Anchor programs. In fact, I would not consider myself as a Rust expert as well. I would say just go ahead and start with Soul Dev's course. I think it's simply souldev.app/course. That is a good starting point. Just go there and understand the basics. Also use Solana Cookbook to understand core concepts. You don't want to miss those. SolanaCookbook.com, if I'm not wrong. Just go to these places. You just need to understand some basic and important concepts first. And then what I would say is just get started with building programs. Trust me, it's not hard. Just copy the code, modify it slightly, and you would learn much more than trying to follow a very structured path to first learn Anchor or something like that. Can I start learning Rust without well, but once again, I think with Rust, it's Rust is a like relatively hard language. The syntax is a bit scary for some people, but I would say just start building programs. Just build hello world programs, build an escrow program, build a counter program, and you would learn eventually yourself. If you have any questions, feel free to ask, because asking questions is very important. Everyone is very helpful, and just go to Solana Stack Exchange as well. There are a lot of answers there as well. I'm using VS Code. This is VS Code. And this is SoulPG. I would recommend, yeah, also, I would definitely recommend just use SoulPG as a beginner. It will make your life a lot easier. Like you don't need to worry about installation and stuff. Just use SoulPG to build your Solana programs. Once you're comfortable, then you can get started with working locally. We just have 1 minute left. So we can continue on Discord. Just message me. I'm also on Super Team server, so you can message me as well. Or I'm also on Twitter with this 0